That's right, in this video we're going to take a look at how to make our NavMesh agents move along a curved path instead of the more robotic linear path that they normally take.
Hey, Chris here from LlamAcademy, here to help you, yes you, make your game dev dreams become a reality in 2022. Happy New Year! This is a video I've been wanting to get to for a while now, where we're going to make the NavMesh agents move on a curved path instead of moving kind of more robotically like they normally do with just the default pathfinding. The concept of what we're going to do here is pretty simple. We're going to calculate a path from wherever the agent is to wherever they're going to go, and then we're going to smooth out that path using Bezier Curves, which we've done a video on already. There's going to be a link in the description so you can check that one out, where we're going to go more in depth into how Bezier Curves work. But using those Bezier Curves, we're going to smooth out that path and then move the agent along that path. But we do need to post-process this path, because sometimes whenever we're using a Bezier Curve to smooth it out, based on our configuration, maybe they'll be going in the wrong direction because we've over-smoothed it. Maybe the points that we chose were not actually on the nav mesh. And maybe the points are so close together that the agent should just ignore some of those points and just move to the next one.
I've got to give a huge shout out to my Patreon supporters. Every single one of you helps this channel reach more people, which means more people are making their game development dreams become a reality. If you want to become a supporter, you can go to patreon.com/LlamAcademy, get your name up here on the screen, on the GitHub repos, and get a voice shout out starting at the silver tier, and some other cool perks too. Speaking of those silver tier supporters, I've got Raphael, Andrew Bowen, and Gerald Anderson. I am incredibly grateful for your support. Thank you. I have a very simple scene here. It's simply a box with some walls around it where the NavMesh agent can walk around where there's blue, and obviously on the orange they cannot because they're too tall for the agent to get on. What we're going to look at first is click to move with the path smoothing turned off. This is the normal just click to move that you'll see in a bunch of videos. I even have a video about it. And you can see it's very obvious whenever they hit one of the corners, because they walk in a straight line to that and then start turning and walk in a straight line to the next one. It does look a little bit curved whenever the agent gets to these corners because the agent has some angular velocity and they don't just abruptly immediately turn. But it's still pretty clear that they're walking between point 1, point 2, and point 3. Once we turn on path smoothing, some of these configuration variables are taken into account. We're going to go over what those are in just a little bit, but let's use these values of 3, 10, and 0 for now. We'll see the path that the agent wants to take to get to this place, and the path is smoothed and a little bit squiggly on the way there. They're not walking only in straight lines. We can play around with some of these values with the smoothing length and the smoothing factor to get different results on how the agent will path. If we adjust the smoothing length to be too long though, we end up with some really weird behaviors, and even if we up the smoothing factor to try to combat that, it still doesn't work perfectly. When I set the path smoothing to be 5, you'll see that there are a lot of points that are taking the agent in the wrong direction. This is what I'm going to call oversmoothing, and to combat that some, we use the smoothing factor. But sometimes even setting the smoothing factor to be a very high number does not fully resolve this problem. So when I set it to 0.95, you'll see that still there are some points that are going in the wrong direction. That's because we're trying to get the agent to go to the point at the end of a Bezier curve. So eventually the agent needs to come back to the endpoint of the Bezier curve, or the start point of the next Bezier curve. To achieve this, what we did is combine what we did with the keyboard movement video. We're moving the agent between each of these points. But instead of using the keyboard movement like we did in that other video, we're assigning the movement vector based on these path locations, which, how do we get those? Those come from the NavMesh.CalculatePath, and then we've smoothed out that path using Bezier Curves. The way that we apply the smoothing is the exact same way that we did in the automatic line smoothing using Bezier Curves video that I did a few weeks ago. The concept of that is we're going to take the NavMeshPath that we were given from the calculate path. We're going to create a Bezier curve for each segment of that path, calculate the previous direction and the next direction, automatically place the start and end tangents based on those two directions and the smoothing length, and then at the very end we'll go ahead and retroactively apply the end tangent. If none of that makes any sense to you, I highly recommend you go back and watch the automatic line smoothing and Bezier curves, where I go over how this works in a little bit more depth. That's linked in the description, and there's a card on the screen. Once we've created all of these Bezier curves and appropriately applied the tangents, we need to get all of the segments on that Bezier curve. So again, this is almost the exact same thing we did before, just this time we're adding it to a path locations that we're going to use to move the agent on. And that's where the smoothing sections comes into play. The higher value this is, the more accurately we will represent the Bezier curve, because we'll do less interpolation between points, because the points will be closer together. And you'll notice there's this one extra line here where we set path locations equal to post-process path. This is because those curves that we made maybe go in the wrong direction, and maybe we just have too many points in a small area that's going to make the agent move a little bit weird. You'll remember from that previous video, if you set the smoothing length to be too high, you'll get some weird results sometimes. So what we do in the post-processing of paths is First, remove the oversmoothing. That's where we have the next point going in the wrong direction based on that smoothing factor. For each subsegment that we've calculated on that Bezier curve, if that is going in a direction that is too far in the wrong direction based on the dot product of the target direction and the segment direction, we'll basically remove that segment. So that way we only have points that are going in the correct direction. I'm removing it by setting it to this infinity vector, which is just vector 3 with all 3 options being infinity. And at the end, we go through and use path.accept infinity vector, which just removes all of those infinity vectors from our array. And we have some logging here, so whenever you pull up this from the GitHub repo and run it yourself, you can see the difference between what was originally calculated and what has been trimmed. Once we've removed the oversmoothing, sometimes we have a bunch of points really close together, especially if you set the smoothing segments to be very high. So what we're going to do is clean up this path a little bit and remove points that are too close to one another, and we're going to base that on the agent radius. So if the distance between the last point and the next point is less than or equal to the agent radius, then we're just going to go ahead and exclude that, doing the same thing where we set to the infinity vector, and at the end we do path.accept, which again removes all of those infinity vectors from the array. Accept is a function that gets added to the arrays by the system.link library. There's one last thing that we need to do on the post-processing, and that is make sure that all the points we've calculated on this Bezier curve are actually on the NavMesh, otherwise we're never going to move the agent to that point. And we do that simply by going over the path and check if we can NavMesh.SamplePosition from the path using the agent radius times 1.5f. You can adjust that value as needed and make sure that we're sampling on the agent area mask. We'll assign the path at that index to be that hit position, so we've just modified that path. And again, if we can't find a NavMesh point, we're going to set that index to be the infinity vector, and at the end do path.accept again with the infinity vector. If you pull this repository, it's important to note that there's an enable click to move boolean on the smooth agent mover that will allow you to left click anywhere in the scene. There's also something called the path setter that will run through these scenarios you've been seeing in the background without having you have to left click to move at all. The path setter allows you to compare different configurations of the smooth agent movement and compare that to when you have no smoothing applied at all. That way you can see if you like the configuration you've chosen and if that works well and how different that is compared to a non-smooth path. Now that we've seen how this works in the code, let's look at how the agent moves with smoothing turned on versus when it's turned off. I'm using a smoothing length of 2.5, smoothing sections of 10, and a smoothing factor of 0 right now. And that means that we're going 2.5 units off to the side of each of the points with the Bezier curves. We're generating 10 subpoints on each curve, and we're pretty lax on keeping points because it just needs to be generally in the right direction, just not going backwards. We'll see that the agent does have a pretty curvy path. The path that's generated does have some points going in the wrong direction, but luckily because the agent's radius is not super small, some of those are automatically avoided because the agent is close enough to them. On some of the paths, you can obviously see that the agent is moving significantly more curved, and on some of them, they look not significantly different. Where you can tell the most that the curved path is coming into play is whenever we're looking at the long straight sections, because those are curved, and when the NavMesh agent moves by default, they move in a straight line going to those. As the agent comes to the corners, a lot of the times with their angular velocity, they still have a relatively rounded path around those, so it's less obvious that the smoothing is being applied. You can of course play with all of these values to see what feels best in your game based on your scenes. And since this is simply a configuration, you can of course change these based on different scenes, where maybe on tighter scenes like this, you have smaller smoothing lengths, and maybe on more open world ones, you can choose larger ones. Using a variety of these different configuration methods we have with the smoothing length, the smoothing sections, and the smoothing factor, you can get a pretty nice curved path, though it's not perfect. You saw that if we set the smoothing length to be too high, then sometimes we get some really crazy paths. There's probably some more post-processing you can do, and also probably some better ways to place the tangent points on the Bezier curves, additional logic that maybe I just haven't done yet. But this does get you on the right track to get some pretty nice curved paths for your NavMesh agents, though this does take a lot of extra processing to get to that curved path. So whenever you're implementing this into your game, really consider, do you need the curved paths, or is the default one good enough for you? I'll leave it up to you to make that decision. It is pretty cool to see the agents move with a less robotic movement, so I would definitely see that there are some games that would get a lot of benefit out of having this kind of movement. If you got value out of this video or the AI series, please consider liking and subscribing to help the channel grow, reach more people, and add value to more people. There's new videos posted every Tuesday, and I'll see you next week.